Hi, welcome to Data Platform Summit. I'm Alex Yates and we're going to talk about zero downtime today. I'm really excited to be speaking at Data Platform Summit. I attended their first time a few years ago in person, back when we flew out to India, doing it online now because of world events, but I'm really happy to be back here again. This session is pre-recorded, but I'm going to be online on the chat while this is playing. So if you've got any questions, pop it into the chat window and I will respond as quick as I can. Let's get started. Right, I want to talk today about zero downtime database releases. The reason I want to talk about zero downtime database releases is for various reasons that I'll come on to explain. I think this is the key to unlocking serious productivity and efficiency and success within your development process. I think it's when we require downtime that we end up having so many problems. So this session is aiming to fix that. Before I get started, I should probably tell you a little bit about me. My name is Alex Yates. I'm a DevOps coach, mentor, focuses on database stuff for DLM consultants. If you want to work with me, there are all my contact details. I am also a big fan of the community, so I am one of the co-organisers of Data Relay, which is a conference in the UK. If you're ever over in the UK, do come check us out. Except in the current climate, we're doing everything online, so check out our online stuff as well. I'm also created a website called Speaking Mentors a few years ago, and a bunch of people have joined me in an effort to provide speaking mentoring for anybody that wants to get into speaking. So on that front, if you want to get into speaking, it's been enormous for my career. It's been brilliant. If you want to get into speaking, check out our website. We've got a whole bunch of experienced speakers who have signed up to say, I'm here and I'm willing to help somebody else take that leap just because it's a great thing to do for the community. There's no sign up fee. I don't hold any data. It's just literally a posting board of people who are saying, I'm here and I'm happy to mentor people to help you get into speaking. So do check it out. I'd love it to see you speaking at a conference soon too. Back to the show. So as I said, Data Relay, Speaking Mentors, and for all of that effort, Microsoft has awarded me a Microsoft MVP award for a few years, and I'm really proud of that. So that's me. I'm today going to talk about, as I said, zero downtime releases. What I'm not going to talk about in a huge amount of detail is any of these things. I'm kind of assuming these are a given. We do need to be keeping our stuff in source control. That's kind of necessary for any sort of database DevOps automation-y type stuff. So if you've not done that, that's fine. It's basically the idea of making sure we have versions of our databases and we keep them saved in Git or TFS or whatever else you want to save your scripts in that maintains a version. We also want to care about automated deployment pipelines. I don't care whether you use Azure DevOps or Jenkins or Octopus Deploy or something else. I'm not going to get into any of that, but you want to have some capability for automated deployment within your team. Finally, a bunch of the techniques I'm going to talk about today are very heavily based on infrastructure as code. ARM templates, Terraform, CloudFormation. I don't really care what tool you use for spinning up infrastructure. We're not going to get too deep into the weeds with that, but it is a critical capability that's going to be really important for you probably to do this. So I'm just calling out here that these capabilities are really important. I'm not going to talk about them in a huge amount of detail, but I'm kind of going to assume that you have some experience within your team about those things. Cool. So how many times when you do a deployment does it feel a bit like this? Especially if we're deploying on a Friday. A lot of the time we feel this way because our deployments look like this. There it goes. Going. Well, that's a bit predictable really, isn't it? The problem is that as our deployments get really, really big, they're invariably going to fail. As Chuck Rossi put it at Facebook, if we want more changes, we need more deployments. And the reason for that is, while he was at Facebook, he observed that the bigger a deployment got, the more likely it was to fail. And once you get to a critical point, the deployment is just too big and too complex, and something is inevitably going to go wrong. The flip side of this is that the business isn't going to be very happy with you releasing less getting less stuff done. So if you're limited on the number of deploys you can make, they have to be bigger deploys in order to maintain the same throughput. Big deploys don't work. So if you're going to have smaller deploys, you have to deploy more frequently. If you want more changes, we need more deployments. Now, one of the problems that you often see is when something goes wrong, people tend to put various bureaucracy and testing and approvals and stuff in front of it to try and make sure the release is safe. And I completely understand the mentality here. If you had a big screw up, you want to make sure that in the future you don't have it again. So you want to put a certain amount of rigor and caution around the release next time you do it. The problem is that so often that increases the amount of time it takes to get something out the door. And if you're creating delays in the process because you have to do more testing, the response to that is either going to be you do less stuff, and senior management isn't going to be happy with that because we're all under pressure to do more stuff more often. So the other thing that's going to happen is you get bigger releases. They are less frequent and they are bigger, which results in more failures. Nicole Forsgren in Accelerate, which is this book here, which is one of my favorite books about DevOps. And if you're interested in any of the data behind it, you should definitely go read it. It's excellent. Nicole Forsgren did an awful lot of research on some of the largest data sets that this research has been done on in our industry. She looked at the State of DevOps reports from 2013 to 17, I think it was. It was 4 years worth. And one of the stark conclusions that came out of her research is that approval by an external body, such as a manager or a change approval board, simply doesn't work to increase the stability of production systems. And it's because of the point I just made. If your approval process slows down your ability to get changes into production, you're actually creating more risk. You don't see it because it's kind of a risk over here, and people don't appreciate it, but you are actually making the problem worse, not better. In fact, she discovered that it is in fact worse than having no change approval process at all. These change approval processes actively create more harm than good most of the time. If you want testing and approvals and things like this to work well, you have to do it in a way that does not slow down the deployment. You cannot be doing a weekly change approval board where all of the changes get batched up for a week. That just doesn't work. What you need is some sort of automated or fast way to approve the changes. If you are going to have an approval, the person who is approving it should be subservient to the change itself. What I mean is the change doesn't work for the person. Sorry, the change doesn't wait for the person who needs to approve it. The person who needs to approve it is waiting for the change to come through. And as soon as it comes through, it's done. The most important thing is getting that change approved and out into production. And almost anything else that you're doing is less important than releasing work that's being completed. But we run into a problem here. If we are restricted to downtime windows, if we're not allowed to make changes except for during a specific downtime window, there is a limiting factor on how frequently we can push our changes out. And as I stated before, the longer we wait between our releases, typically the bigger and more complicated and more risky those releases are. So this whole concept of downtime windows actually generally creates risk all of its own. And there are all sorts of stories about things going wrong and missing downtime windows and stuff not coming up when it needs to. If you've ever read the Phoenix Project, there is like one of the biggest calamities in that book is where they had a big disaster that was database related, and then when they weren't able to bring up all the systems for Monday morning, and their global sales and marketing systems just didn't work. So yes, we need to make sure that any approval processes and testing processes that we put in are automated, are fast, and they do not slow down our release frequency. How do you do this? Well, as Art Gillespie says, deployment need not expose customers to new versions of your service. And what he's getting on here is a distinction between deployment and release. And now, Deployment and release, lots of people use these terms differently. Release management tools like to think about kind of your releases, putting all your bits and pieces together, and then the deployment is actually pushing it onto the server. But a lot of people in the DevOps community think of it slightly differently. So the way that Art Gillespie defines it is a deployment is changing some files. A release is exposing that change to your users. And the key issue here is, what if you could deploy your changes in advance without your users ever seeing them? What if by the time it comes to your release date, when you show it to your customers, the code has already been sitting and running behind the scenes in production for weeks? You know that it works because it's been doing so for weeks already. And if your release goes wrong, you can probably flip back to the old version with a simple setting. Suddenly, I'm not worried about upsetting my user. I don't need to sync up with marketing release schedules. I can get my stuff into production ahead of the marketing release. I can test it ahead of the marketing release, and then I can change over. I don't need to do a risky deployment where I'm changing a lot of bits and bytes on the release date. With zero downtime windows, what if I could get all of my code running into production in a way that avoids any interruption of service? Suddenly now I'm breaking one of those big barriers that's pushing us to these big risky monolithic deployments. I'm able to do it in a way that results in lots and lots of smaller iterative changes that are much easier to roll back and far less damaging when they go wrong. And that's the whole point of zero downtime. Now, there are a few different approaches that you can take to zero downtime, and there are a few different strategies. And what I'm going to do in this session, first of all, is give you an overview of how various different strategies work to achieve this. Now, actually, this session is all about databases, and it is. But before we talk about the databases, we do need to understand a little bit about what else is happening, because rarely does a database live in isolation. Typically, we have applications that are calling it and all sorts of other things. We've got these dependencies, and it's those dependencies that are the real difficulty when it comes to zero downtime. So in order to talk about this from a database perspective, we have to first look at the big picture. So that's what we're going to do. We're going to start by talking about blue-green deployments, canary releases, dark launching, and all of the various different ways that people do it. And then after we've talked about it kind of from an application tier, we're then going to talk about the consequences on the database and what we need to do within database land to support our allies who are working on other parts of the system, because we're presumably all trying to work together in one big team. So let's get started. The various release patterns are split into environment-based releases and application-based releases, or environment-based patterns and application-based patterns. Typically, the environment-based ones do fun stuff with infrastructure as code and clever load balancing tricks to spin up new servers and tear them down and put servers into rotation and out of rotation. And the application-based stuff is more code-based, so it's not so much about building and throwing away new infrastructure. It's more kind of setting flags in code. But we'll get onto that. So let's take a little look at blue-green releases first of all. So let's imagine this is my very basic architecture. I'm not worrying too much about the data tier at the moment. I know that as I go through this, a lot of you are database people and you're going to be thinking, what about the database? I know that. Hold that thought. We will get to it. What we're going to talk about right now is you've got users. They send a web request, they hit your load balancer, and that load balancer directs them to whichever server is going to serve them the website or whatever else it is that you're working with. So to begin with, we've got a bunch of happy users. They're working together, they're hitting my web farm, and I've got the green or the old version of the code running on my infrastructure. And what I want to do is I want to release a new version. The first thing I'm going to do is I'm going to redeploy an entire production suite over here, somewhere else, somewhere not connected, and I'm going to put my blue version or my new version there. Now, nobody's touching this yet, so I have the opportunity to test it however I like. Maybe that's manually by logging on and hitting servers. Maybe I've got a QA team or whatever that want to hit this and do whatever they do manually. Maybe I've got a bunch of automated tests. Maybe I want to do a bunch of load testing on it, simulate a bunch of traffic, whatever I want to do. I'll leave that as a task for the user. That's a different talk about testing and anomaly detection and all of that sort of stuff. What we're doing now is we're focusing purely on just build it. Let's see if it works. If it does, great. And when I'm happy with it, I can then just switch the load balancer over. That's one setting on the load balancer. It's really, really easy to do if you understand load balancers. And then if anything goes wrong, if my users are unhappy because it turns out I did break something, there was something I missed, because we are going to make mistakes. Like, zero downtime is not pretending I'm not pretending we're never going to make mistakes. If anything, zero downtime is acknowledging the fact mistakes are going to be made, and it's aiming to give you really good fixes to those problems. The great thing about blue-green is if there's a problem, I can just switch the traffic back to the old site. It's pretty much instantaneous because all of the old stuff is still there. It's still ready to go as soon as it's needed. So because I'm not doing any sort of in situ upgrade, the release doesn't actually have a deployment attached to it. Remember what I said before, deployment is changing files, building new servers, updating code. Releases is exposing it to my users. So the deployment happens well in advance. The release is a simple flag in the load balancer, send it over here rather than over there. And if anything goes wrong, I can just send it back the other way. Super quick, super simple to undo my mistake. And that's good. This probably already feels an awful lot better, like a much easier rollback strategy than a lot of us already have. Certainly, I don't want to be worrying about updating servers anymore when I want to roll back. I just want to be able to point back at the old version. But we can do better than this. In the process, for whatever period of time it was, I had a bunch of unhappy users, and actually all of my users were unhappy. Let's say there was 10 minutes between rolling out the blue version and then rolling back to the green version. For that 10-minute period, all of my customers were upset. How could I do better? Well, one thing we can do is canary releases. So with a canary release, we don't do a switch over all in one go. We just put one of the blue instances into rotation. In this scenario, I've got 4 web servers currently running in production in a much bigger estate. Maybe I've got 100 or 1,000, and I'm only exposing the new version to 1% or 0.1% of the total number of users. So if any of those users are unhappy, well, that sucks. I'm sorry, we made a mistake. But we've only affected a tiny sliver of our total number of users for a very short period of time. So once again, I've made another order of magnitude improvement in the safety of my system, because the effect of any problem is significantly more restricted. If it goes wrong, I can take that server out of rotation. I can go away, back to the drawing board, fix the code, figure out what went wrong, and then I can have another go. And this time, when I put the blue one in, hopefully this time I've got happy users, great, and then I can gradually roll it out kind of one server at a time, or I can do it in batches until eventually I'm up to 100% of people using the new version. So that's really cool. It allows me to gradually throttle up the number of people using the new system, which is really handy for spotting things like performance issues. Because maybe you didn't see the performance issue right away with just 1% of the web farm using the new version, but as you scale up to 2 and 5 and 10% and you gradually increase it, that's when you begin to figure out something's a bit fishy, something's a bit off here. Let's pause this rollout until we've figured out what's going on. Cluster immune systems are basically a fancy version of canary releases, but it relies an awful lot more on automated telemetry and anomaly detection and stuff. So what I'm doing here is when I put the blue one into rotation, it might take a bunch of time for users to report issues, but if I've got a bunch of automated stuff in there that can just spot, hey, we don't normally see this level of CPU or this number of web requests or whatever else. And if anything looks a bit funny, we can just automatically throw it back until we understand why we were having that fun performance. This gets into a whole separate area of automated smoke testing, anomaly detection, telemetry monitoring. Again, I'm not going to go into detail in any of that stuff. Go to one of the sessions that goes deep on those things to kind of figure out how to do that really well. This isn't something you do on day one. This is something you build up to. But once you get there, it's really, really cool. So that's your environment-based stuff. It's generally, as I say, it relies a lot on infrastructure as code, the ability to spin up servers and throw them down. It kind of rejects the old idea of kind of on-prem servers. This is my production server. No, your servers should be able to be disposable, spin them up, throw them down from a script, from a source controlled definition of what your server should look like, and iterate from there. So that's how we would like to manage our server in the new world if we're using environment-based release patterns. The next thing we're going to talk about is application-based release patterns. These aim to effectively serve the same purpose, but in a very different way. And what I'm really talking about here is feature toggles or feature flags. People use the two terms independently. The code on this slide I've completely stolen from Martin Fowler's excellent blog post about feature toggles. I do encourage you to go and read it. So let's say this is the original version of my code, and here I stole this from Martin Fowler, so it looks like Java to me. But hopefully anybody who's reasonably literate with code can kind of understand what's going on. So this is the old version of my function, and that's where the old implementation lives. If I didn't want to do anything with the servers, maybe I don't have the authority to play with the physical hardware. Maybe my organization still runs on-prem, and just the level of infrastructure of code that I was talking about before just is beyond you, or it's not practical in the short term. Well, here's something that pretty much anybody can do when they're writing code. So here is your old version of your function. And the first thing we're going to do is we're going to create another function, the old-fashioned version, which is just a copy. Now, at the moment, nothing is calling it. Nothing is calling that function because everything's calling the original function. So this is just a complete carbon copy of the old version of the code. We then write a new version of the code, something we think is going to work better, something to implement some new feature, whatever it is we want to do. Again, nobody is calling this yet until we go back and change our original function like this. So we set some variable, use new algorithm. This is our flag. We'll set it to false by default. If you want to switch the new version on, then you can see just a couple of lines below that. We can uncomment that line where we override the value to set it to true. And then we replace the previous implementation with a simple if statement. If we're using the new algorithm, run that version of the function, otherwise use this version of the function. Now, when I'm developing locally, it's really easy for me to toggle between this version and that version as a developer just by hitting a single variable. I can have both versions running on my system at the same time. And I can benchmark stuff. I can say, let's run it with the old version, let's run it with the new version, which one performs better, does it do the same thing? I can run the same unit tests against both the old implementation and the new implementation and check that kind of everything works as it's supposed to. So this works really well in the development domain. In the production domain, typically what we're likely to do is replace this kind of hard-coded variable with some sort of call to an external database. So I might have some external database that just contains a bunch of configuration code, and I can just flip a bit in that database, and now this function will call this version of the implementation rather than that version. And what this means is I can deploy this version of the code to production, and I've not actually changed the behavior. My users have not seen any difference in behavior. This is working completely fine. And then when I release it, all I need to do is flip a bit in the configuration database, change a 0 to a 1 somewhere, and I'm using the new version. If everything blows up, I can just flip it straight back again. Again, I'm mainly thinking about applications here. The database people are thinking of all of the problems that are about to happen, and I see you, we'll get to you. But this is how feature toggles or feature flags work. And it's a very clever way to be able to separate my production deployment from the actual marketing release effectively. So how would this work in real life? Well, again, here I have my users, my load balancer, and my production instance. This time, you'll be happy to hear, if you don't like load balancers, you don't need to touch the load balancer at all. This is all going to be managed through application code rather than load balancers. So again, I've deployed the feature flag version of the code to all of my instances. I was able to do that while the thing was running because there was no functional difference, and I've got a big enough web farm of applications that when one of them is down, then one of the other ones can pick up the slack. So we're good. Then what I can do using my configuration database is I can just flip one of them to true. And oh dear, my automated telemetry has got a problem. My users have started screaming at me. Fine, I can just flip that bit back again and I'm back to safety. I can look into the issue, try and figure out what went wrong, try and fix the issue, and then we can try again. This time it worked fine, but it turns out the users just don't like the feature as much. And that's one of the really cool things about feature flags. It allows us to be really scientific. Software development is expensive, right? And so often we're told to do this or that because somebody feels like it's a good idea. And actually it's staggering the amount of investment that gets made in changes, and we have no idea whether it's working or not. By doing it like this, it gives us a really smart way to kind of A/B test different approaches. Marketing wanted me to change the website like this because they thought it was going to increase click-throughs or increase the number of transactions or whatever. Great, well, let's run the green version and the blue version side by side for a while, and let's look at which one actually works. In this case, functionally it worked. As a developer, I did everything I was told to do, but you know what? It's just not working as well as the green version. People like the old version better. Well, this is an opportunity to go away, do a bit of thinking and iterate, and maybe I'll pop it back to the green version for now because the green version was performing better, and eventually I'll pop the blue one out there, and that now seems to be working because I fixed it, and then gradually I can roll that out. This approach allows us to be a lot more scientific with our process, and this goes beyond software development. This is a much more business-oriented thing. As a developer, you instinctively understand that the quicker the feedback between writing some code and seeing whether it works, the quicker you get that feedback, the better your development experience, and the easier it is for you to write a really nice piece of code. The same is true for the business, in marketing, in sales. Typically, if your marketeers are running a marketing campaign, they spend weeks planning it, then they deliver it, then if they're lucky they'll get some sort of feedback and data about what actually worked, and this whole cycle might take months. Imagine if we as developers can give them the tools that they need to be able to, side by side, try different marketing approaches on your website or your product or whatever else. Suddenly now we're not talking about an engineering benefit, we are talking about like a company competitive advantage that's going to propel your company to success. That's why this stuff is really, really important. We also want to talk about dark launches. Now, dark launches are basically just feature flags, but they're doing something a little bit different. It's not just turning on the functionality and turning it off. What it's doing is running the new functionality, just not exposing it to users. And to demonstrate this, I'm going to use a case study that comes from the DevOps Handbook, which is an excellent book. Oh, look at that. It's a really funny color because of all my funky green screen stuff that I'm doing to present. Ooh, there we are. If I do that, I think you see the actual color of the book. How funny. I'm learning with all this video editing stuff. So what happened was Facebook, back in the day when Facebook was fairly early, I'm old enough to remember when it first came out. When I first started using Facebook, there was no instant messaging feature. It was pretty much an asynchronous communication tool. It wasn't synchronous at all. You'd post on your page, and then if you wanted to actually chat IM with somebody, you'd hop over to MSN Messenger or something else, Skype maybe. And Facebook wanted to keep you in their ecosystem. They wanted to keep you within Facebook when you want to do that IM. They wanted to add IM to their product. Now, when you are IMing, what they wanted to do was show you a pop-up of who's online right now. So it would say, here are all of your friends. And at the top, you'll have the people who are online right now, with a little green icon next to them. And at the bottom, you'll have the ones that are offline. Cool. Sounds like a good trick. You come online, you can see who you can chat to, and you can just start talking to them. Fantastic. 10, 15, 20 years ago, whenever it was, that was kind of leading edge stuff. That was new. We hadn't seen that before. The problem with this is that query to figure out which of your friends are online and which of your friends are not online does not scale well. The more friends you have, the more people who are doing this at the same time, the worse the performance gets. So Facebook were really worried that if they open up this new feature with a big fanfare about you can do IM now on Facebook, that they were just going to suffer all sorts of performance issues and take the site down. And that's not something they were willing to commit. So what they did is, as they were developing this new feature, they ran it in production for a tiny slither of their users. They just didn't expose it in the UI. They didn't even have a UI for it at first. All they were trying to do is figure out, can we figure out which of your friends are online and which ones aren't? Like, building the UI comes afterwards. That's relatively easy. It was the algorithm to figure out who's online and who's not that was hard. And gradually, as they refined it, as they understood the performance implications and what they could do and what they couldn't do to run it in a way that wasn't going to take down the whole of Facebook, they were gradually able to roll it out in the background across more regions and more people, until eventually they were running it in the background at full capacity for everybody. They just hadn't shown people the UI yet. And so when the release came along, it was a simple flag, and now you're running the new version of it, and now you can see it. And it was incredibly smooth because they'd already figured out all the performance bottlenecks beforehand. They were not redeploying the code all at once and running it for the first time in production in one go in some downtime window at the time. They were doing it in the background and building it up. And that led to significantly more safety. It was a flawless release by the standards at the time. Cool. So we've talked about various different release strategies, and we've talked about it mainly from an application perspective or a web perspective. Blue-green deployments, the simple switchover. Canaries, where we gradually put in, add more servers into rotation. Cluster immune systems, where we're doing a bunch of anomaly detection on it. We've also talked about feature toggles and dark launches. Now let's talk about databases. So obviously, if I've got a green version and a blue version, and they're likely to be running at the same time, what does that mean for the database? Well, there are a couple of things we could do. We could run a separate green database and a separate blue database, and we can switch over from one database to the other. But we really don't want to be doing this. We really don't want to be doing this because the synchronization issues you're going to have between blue and it's just horrible. It's no end of problems. The switchover is nasty. It's just, don't do it. What you want to do is have the blue version and the green version both talking to the same version of the database. This has challenges, but it's a much easier way to solve this problem. It means that you need to support some level of backward compatibility. You need to be deliberate about it. And you need to make sure that you're working in tight collaboration with the various other people who are looking after the various dependent systems. So how does this look in practice? Let's talk through an example scenario. We're going to be using the expand contract model, which Scott Ambler and Pramod Sadalaj talk about in refactoring databases, and it's talked about in various other places as well. Basically, we need to add the new schema objects. We then do our blue-green switchover, and that all happens in the background. And then afterwards, there's a tidy up phase where we need to take the old stuff out. And we do need to clean up after ourselves, because otherwise we just create these monolithic, complicated databases and nobody knows what's being used anymore. So the cleanup phase is really important. And I promise you that managers will want you to cut corners, because they won't want you to clean up the old thing because they want to do the new thing, and cleaning up the old thing doesn't help get the new thing out any more quickly. But you have to push back on it because you have to clean up the old thing, because otherwise you end up with these horrific databases with tables called to delete all over the place, and you don't even know whether you can really delete them, and so forth. So let's talk about that. I'm going to use the example of splitting a column, a full name column, into a first name, last name, because we used to do full name, but then we were doing all sorts of string concatenation when we want to send emails saying hello first name, and we're getting it wrong all the time because not all names follow Western standards, and people are sticking prefixes in there, and we want to solve all of those problems. So what do? Well, the first thing we do is we add first name and last name columns. And the blue version is the new version that we want. The green version is the existing version, and neither of these versions are going to work for both versions. If I have blue applications calling the green version of the database, I'm going to have problems because they're selecting first name and last name, but they're not there. Similarly, the green version of the application calling the blue version of the database isn't going to work either. So what we have to do is we have to have everything in there. That's what we need to have during this transition phase. So our process is going to look like this once we add together all the application tier stuff and all the database stuff. So the first thing that we're going to do is create our new columns. The next thing that we're going to do is copy across the data, and this can be done as a background job, just a few rows at a time, dribble it across to make sure that we're not hammering performance all in one go. The fact that we don't need to do this during a downtime window is going to help us an awful lot, because we don't need to worry about having this all done by any specific deadline. We will continue with the deployment once this bit is finished. We can focus on one thing at a time, and copying some data across, that's a relatively small piece of the problem that we can solve by itself, rather than having to get it tangled up with everything else. The next thing we can do is flip our feature toggle, or release our canary, or whatever we want to do, and check that everything's working. If it fails, then obviously we can unflip it and we can go back and fix whatever the issue was, and then we can try again. This time everything is still working, and if everything goes well, then we can gradually roll this out until all of the applications are running the blue version, and then eventually we can delete the old version of the column once we know we don't need it. One thing you might want to do is before you delete it, just rename it. So such and such a column _to delete. Make sure you add a date that it's going to be deleted on as well. That often helps when you're looking back at a whole bunch of to delete tables and you're not really sure whether you can delete it yet. Well, if you put a date on there, then you know, well, it's past that date. It can be deleted, because whatever other applications have had enough time to verify that everything is still working. Other things you can do is try and track traffic to that table to see if anybody's actually still reading it. If you do all of your data access through stored procedures or views or something, then that can also help you with this sort of stuff, rather than having the applications call the tables directly. There are various strategies to making that as safe as you can make it. And there we are. We've managed to make this change that in the before we had our blue-green release strategy, beforehand, that would have probably required a downtime window, take everything offline, update the database, change the applications, bring everything back online, cross our fingers. If everything goes wrong, then we've got a nasty problem. Well, now we've done it in a way, we just did it one step at a time, and at every single point we had an easy step to roll back. So this is much safer, and you don't even need to tell your users this is happening, because this is a behind-the-scenes task that your users aren't going to know about. So this is something that really shouldn't require a significant amount of approval bureaucracy to go through. Obviously, there might be data protection or regulations that you need to deal with, and that's a kind of separate problem. But for just generally upsetting your users and taking the system offline and bringing it back online, it's possible to do it without downtime windows. Yes, it's harder. It is harder. It's more complicated. Nobody said that safe automated releases was easy, but it's significantly safer. So this is where we're going to jump into a demo. So in this demo, we're going to recreate the Facebook chat case study that I mentioned earlier on. What we have to begin with is a Facebook database, which contains a users table and a relationships table. We already have a friends of X stored procedure, which will return all of the IDs of all of the various different friends. What we want to do is find out what those friends' names are and have a little bit of information about them, so we can create a nice little list that we can display to the user of friends. So we need to improve this function, this procedure, and we want to make sure that we're taking performance into account while we do that. All of the code for this demo is available on my GitHub page. You can see the URL up there, github.com/Alex-Yates/0downtime. You can go there. You've got all of the scripts that you need to recreate this on your own machine. You've also got the slides for this demo, although this slide deck is full of green screens and stuff that probably is going to be hard to recreate, if I'm honest. So I've cloned this repo, and I've taken and I've used the generate databases, create databases and generate data scripts already. And let's go into SQL Operations Studio. That was old-fashioned, Azure Data Studio. This is the friends of stored procedure, and it does kind of what I did before. Do you remember when I was talking about feature toggles, how how in that reticulate spines Java example, it split the function into kind of sub-functions, and if it's enabled, do this, otherwise do that. Well, I'm kind of doing the same thing, and I've chosen to use dynamic SQL for this. There are, I'm sure, better and worse ways that this could be done. So at the top, I've got a bunch of logic around reading from a feature toggles table in a separate database to determine whether or not this feature is enabled or not. And then this is the original version of the SQL, and this is the new version of the SQL. And since it was written by a web developer, I'm doing the typical thing of using a cursor. And there's a particular line in here that I don't think is going to run particularly efficiently as we're working through our cursor. That's obviously just a bit cheeky of me just to create a really simple performance tuning example that we can play with. So this is our function, and we have this in that's our procedure, and we have in a separate database, a toggles database, we've got a features table which has a feature name, and at the moment you can see it's not enabled. And we're not dark launching it, so we're still using the original version of the code. So we're using the original SQL block of dynamic SQL rather than the new SQL. So let's see how it works. The current version, let's run that. That was reasonably quick, and it gave us a list of Facebook users who are friends with user ID number 5. I'd like a bit more information. I want to know these people's names and various other information. So what I'm going to do is I'm going to dark launch this feature. So at the moment I'm going to be running the new version of the algorithm, but I'm not yet showing the information to the user. So we're doing all the work to retrieve this information, but we're not actually showing it to the user yet. So we're dark launching it. We're not changing the user's experience. We are just doing the extra work we need to in the background. And oh crumbs, this is taking a while. That took significantly longer to run than the previous one. It took 3 or 4 seconds to run, whereas the last one was much more quickly. So crumbs, why don't we scale that back a bit? So you'll see on this dark launch I can throttle this back. So let's throttle it back to 50%, so that we're not running it all the time, because that would hammer my servers. I'm just going to throttle it back a bit while I troubleshoot it. So I'll run this again. That's taking a while. That one probably got the new version that we know has a performance issue. Let's try running it again. That was really quick, so that was probably the original version. That was really quick again. So you can see I'm throttling it now, and some people are hitting it and some people aren't. I'm testing it out on a thinner sliver of my customers in a real world scenario. Rather than clicking it at 50%, I might click it down right down to 1% or a fraction of a percent or something, just so that I can really minimize the amount. Obviously that wouldn't work in this demo. So let's go back to the code and see if we can fix the code. And as I alluded to earlier, there's a bit of a ludicrous line in here this wait for delay line. So we're looping through all of the users of Facebook. We're seeing whether they're friends. And between each check, we are waiting for a 0.2 second delay. So that obviously is a fairly silly, oops, sorry, I'm thinking PowerShell. That is obviously a silly implementation. I've removed that wait. Hopefully now it's going to run a lot faster. So let's go back to my feature toggles. And what I'm going to do is I'm going to whack the throttle back up to 100, just so I know, for demo purposes, I know that I'm definitely getting the new version of the code. I can run it again in the background, and that ran fairly quickly that time. So I fixed my performance issue. I now know that I'm doing the work in the background to figure out all the names and stuff. So let's enable this feature for our users. So I'm going to click the enabled button. Let's turn it on with a single click. And if I come back here and run it, there we are. There's all of the information that's been provided. I knew that was going to be quick. So I was able to, without changing anything to my customer, I separated my deployment from my release. So I was able to do this in much smaller chunks. I was able to control exactly what the impact was going to be when I was making these changes. I was able to think carefully about how many of my users do I really want to expose this new change to. And ultimately, the actual release of this change was super simple. And if I wanted to roll it back, it would be a very easy task to go back to my features table, my feature flags table, and adjust the dials on here, and we're right back to the old functionality that we knew worked perfectly well. So I hope that gives you some food for thought. I'm not necessarily saying this is exactly how you should implement it, and frankly, there are a whole bunch of tools that can do this for you, Launch Darkly and various others. So I do think it's probably a good idea for you to look at what tooling is available before you start trying to build this yourself, because to a certain extent, many parts of this are already a solved problem. A few other pieces of advice: make sure you do clean up after yourself afterwards. Once you've got your feature out there, make sure you do remember to contract the database when you're trying to do backward compatibility. Make sure you, after a point, you kill the old stuff. Try not to have too many feature flags at any one time, because otherwise you just end up with hideously complicated code all over the place. This is a really nice technique, but use it in appropriate moderation, I guess is what I would say, especially when you first get started, because otherwise you'll end up getting into that horrible world of conflicts between this feature flag and that feature flag and all the rest of it. But as I say, in general, this is a really nice trick to be able to use to avoid downtime windows and the necessity for them, to be able to release in much smaller iterations without jumping through 150 different hoops of approval, and to be able to test features in production before you expose those features to your customers, so that on your release day you know that it's going to work. So that pretty much wraps up this presentation. We've talked about the various different sorts of release patterns that are available. We've talked about how they affect the database. We've walked through an example in that demo that we just did. That brings us to an end. What I'm going to do is just call out a few of the resources that I used to create this presentation. So there are a few blog posts that were really useful to me. The deploy not equals release blog post by Art Gillespie. That link isn't working at the moment. I can't find it, but if anybody does find it, please let me know. And then there are a couple of blog posts on Martin Fowler's website, one by Pete Hodgson about feature toggles and another one by Daniel Sato called Parallel Change, which is that expand contract thing. Also, that's Refactoring Databases is a really good book that talks about all that sort of stuff. I also reference all sorts of books. I think my favourite one that I referenced was Accelerate by Nicole Forsgren and Gene Kim and Jez Humble. I wrote if you want to read more books, I like reading books. If you want to read more books, then check out a blog post I wrote for Octopus Deploy, tail end of last year, all about choosing your next DevOps book. It comes with a decision tree that should help you to make a decision because there's so much to read. Trying to figure out what's the right book for you can be quite daunting. So there's this decision tree there which might help you to figure out what is it that you're really interested in and where you're going to go from there. Thanks to all of the sponsors, Microsoft and the various others, for supporting SQL Server Geeks. And please do the selfie hashtag thing to try and win a prize. Follow us on Twitter. Please do the feedback. All of us really appreciate that. The conference, I think, will like all the numbers, and us speakers like the words. We like to know how we could have been better. What did you like? What didn't you like? What do you want to see more of? What do you want to see less of? That's going to help me to become a better presenter. I'm doing this for free. All I'm asking for is feedback to help me improve. Thank you very much. And that brings us to a wrap. So once again, thanks very much, everybody, for having me. I hope you've enjoyed this. I'm still in the chat, so if you want to ask me any more questions, fire away, and I will try and answer those for you. Thanks again, and all the best. I hope you enjoy the rest of your conference. Bye.